All right, welcome to Study Guide Forum. Today we'll be looking at a question. This question has to do with, if you look at this question, I calculate the mass of oxygen required to burn 10.5 grams of magnesium. We have the relative molecular mass of magnesium and relative molecular mass of oxygen. So before you solve this problem, the first thing you need to do here is to write a balanced chemical equation. So when you're able to balance the if you're able to write a balanced chemical equation, that means that is you have at least passed the first step in solving the problem. So the first thing, let's look at the balanced chemical equation. The combustion reaction between magnesium and oxygen goes like this. The chemical equation we have it to be, and this is always the atomic. Then magnesium, that will give us a balanced chemical equation. This question is looking for the mass. That means what we are looking for, and we are also given the mass of magnesium. That means this reaction has to do with, this calculation has to do with mass to mass stoichiometry. That means we are looking for mass, converting mass to mass. So instead of doing that, what we're going to do here to make it easier for the simplest way of solving the problem is looking at the masses involved in the balanced chemical equation. Now, if you look at this, you know that relative atomic mass of magnesium is what? 24. That means 2 times 24 will give us the mass of magnesium that's involved in this chemical reaction. Coming over to this other end, oxygen, that means in this is equivalent to what we have here. Oxygen is diatomic, that means the relative atomic mass of oxygen is 16. That means 16, 2 times 16. That's what we have. This other one should be something like this is 8 and 4 grams of what? Magnesium. While that of oxygen will be 32 grams of oxygen. That means 48 grams of magnesium combines with what? 32 grams of oxygen. Now we're looking at what we have, what is given to us, say 10.5 grams. So if it's like that, that means 10.5 grams of magnesium will then be equal to 32 over 48 times 10 over 10.5 over 1. If we calculate that, we are likely to get 7 grams of oxygen. So this is the fastest and the best way of solving this problem, because there's another method of doing it might be a little bit complex. In the sense, we are going to be considering based on the moles, number of moles that are involved, and then it might be a bit complex. But then looking at taking it from that angle, taking it from the angle of that, what it means is that we are going to convert this to moles. If you convert it to moles, the 10 grams to moles will give us 10.5 divided by what we have as that. We'll have 10 grams divided by 24. 10 grams divided by 24, we have 10.5 grams divided by 24. What we have is equal to 0.438 moles, sorry, not grams this time, moles of magnesium. That's what we have. So now, from the balanced chemical equation, we know that 1 mole of magnesium, 2 moles of magnesium combined with 1 mole of oxygen. So what we do here is to get the number of moles of oxygen required. So in that case, we have 2 moles of magnesium will give us 1 mole. We react with 1 mole of oxygen. Then we have this one. The 10 grams now have been converted to moles. We have 0.438 moles of magnesium. Will then be equal to 1 over 2 times 0.438 moles. So if we are to go by that, that means dividing by 2, we have we have 0.21, approximately 9, say 9 moles of oxygen. So this is what we have. So this is like that. The next thing we are going to do is to convert it, multiply by the molar mass of oxygen. Molar mass of oxygen. If we multiply by molar mass of oxygen, what we have we have 0.219 multiplied by 32, which is the molar mass of oxygen. That means we'll multiply that. What do we have here? We have 0.219 multiplied by 32. So what we have here will be 7 grams. This is another method of this, but I I will suggest that you use the first method, because the first method will make it easier for you to arrive at the answer. Because most time when you work with mode, if you are trying to be a bit fast, you might tend to forget that your answer is not required of word moles. Then because this one you have here is moles, until you convert it to grams, that's when you are able to get, because if we are looking for the mass, remember we are looking for the mass. That's why you move just by mass to mass stoichiometry. Thank you so much for being part of the class, and if you are joining for the first time, make sure you subscribe, like and share. Thank you so much.